Alright folks, today we're working on 7.3, which is solving rational equations. And then we also need to make sure we check for extraneous solutions. So I've labeled 7.3a as solving rational equations and b as checking for extraneous solutions. We have been seeing rational equations for a long time. I just wanted to review that a little bit. We've seen equations like 3 over 4 equals x over 4. These are two ratios. They have an equal sign, so we've got two ratios that have, an equal. Two ratios that have an equal sign mean that that's a rational equation. So we're used to just cross multiplying and going for it. And we can do that. The other thing we can do though is if we notice that our denominators are equal, that says that the numerators are equal. So if the denominators are equal, then the numerators must be equal. So we can try this if we want to. We could say 3 times 4 gives us 12. 4 times x gives us 4x. So we'd say 12 equals 4x divided by 3. We'd get 3. Or we can just go ahead and say, hey, look, x equals 3. So that's all well and good when we have denominators that are equal. If they're not, though, we have to get them to be equal. So let's look at this example I have on the right. So 6 over 5 equals x over 4. X over 4. So these denominators, 5 and 4, are not equal. So we have to look for the least common multiple, which we've talked about this before, of our denominators. So we're looking for the smallest number that both 5 and 4 can multiply to be. Is
I think it's 20 is the smallest one. It will always work out to if you multiply your two terms, you can get the smallest one. It's not always the smallest, but you can always do that if you want to. So we can always say, oh, we know that 4 times 5 is 20. It will always work for us. So to get 5 to be 20, we need to multiply both the top and bottom by 4. To get 4 to be 20, we need to multiply the top and bottom by 5. So basically, take whatever this is, whatever we have to multiply it by, to get that number so that it's the same in the bottom, so we can just set them equal to each other, just like we did over here. We've got to do that. So 4 times 6 is 24. 4 times 5 is 20, divided by, or equals, 5 times x is 5x. 4 times 5 is 20 as well. So we can just say 5x equals 24, or 24 equals 5x. If you want to go backwards, it doesn't really matter. We divide by 5, we get x is going to equal, so if our denominators are equal, we set the numerators equal. That's all I did here. 24 divided by 5 is going to give us 4.8, which we could also just say is 24/5 if you wanted to say that as well. Whatever you're looking for. So we're going to be using this process where we use the least common multiple to solve equations such as this one. So our first step is always, for example 1, we're asked to solve the equation 4 over x equals 3 over x squared. We're asked to find out what x is equal to. So the first thing we should always do is find out what the least common multiple is. So we're looking for the least common multiple of x and x minus 2. And if you remember, you can always just multiply. If you're like, Mr. Seaman, I have no idea how to find the least common multiple of x and x minus 2. That is fine. So we're just going to say the least common multiple is x times x minus 2. Right? I mean, that works. You can multiply this by x minus 2 to get x, so x times x minus 2. You can multiply this by x to get x times x minus 2. So you can just do that. So I'm going to multiply this side of the equation by this part of it. Let's see, I need to have x times x minus 2 in the bottom. I already have an x, so I need to multiply by x times x minus 2 divided by x minus 2. So we have x times x minus 2. On the right side, I need to multiply it. We already have the x minus 2 part. I need to multiply it by the x part. X over x. Remember, we can multiply anything we want by 1. So we're going to write this out. So we're going to have 4 times x minus 2, we just multiplied, divided by x times x minus 2 equals 3 times x is just 3x. Let's simplify that. Divided by x times x minus 2. And now that our denominators are equal, we know we can set the numerators equal, which says we can say 4 times x minus 2 equals 3x, which now, this is a trivial problem for us to solve. This is an algebra 1. Let's distribute. We're going to get 4x minus 8 equals 3x. So I'm going to move my 4x the other side because I already have all my numbers on that side. So I get negative 8 equals, let's see, negative x. Multiply both sides by negative 1 to solve. So I'm going to get
8 equals x. So that's my potential solution. We also need to check for extraneous solutions. That's our part B. So I'm going to take my 8, I'm going to plug it back in for my x in my original problem, and make sure that I get a true statement. So here's my check. So 4 over 8 equals 3 over 8 minus 2. Okay, so 4 over 8 is going to be the same thing as 1/2, which 3 over 8 minus 2 is 3 over 6. 8 minus 2 is 6, and we get 1/2 equals 1/2. And if you're like, Mr. Seaman, I don't know about this, type this in the calculator. 4 divided by 8 is 0.5. 3 divided by 6 is also 0.5. So yes, because we have these two things, they give us true statements, 1/2 equals 1/2 and 0.5 equals 0.5, then yes, this is the solution to that problem. It is not extraneous. Alright, so it's a little bit nicer and simpler when we only have something equal to itself. But you could also have things that have addition or subtraction, and this is where it gets a little more complicated. So we're still going to have to look at the LCM of all three parts. But just like usual, if you see something that is not factored, this is not factored yet, you should make your life easier by factoring it first. So factor first. Always factor first. So I'm going to factor x squared minus 4, which is the same thing as x squared plus 0x's minus 4. So I know that what multiplies to be negative 4 and adds to be 0 is x minus 2 and x plus 2. Negative 2 times positive 2 is negative 4. Negative 2 plus 2 is 0, so this is the factored form. So really, we're looking for the least common multiple of x plus 2, x minus 2 for each of these guys, and x plus 2 times x minus 2. Right? I mean, that's the whole thing. This is what we're looking for. So we're looking for what multiplies to be, what's the smallest thing each of these can multiply to be. So if we multiplied x plus 2 times x minus 2, we'd get x plus 2 times x minus 2. So we can just say our LCM is just x plus 2 times x minus 2, which is easy for this right side. After we simplified it, we're going to have 10x minus 2 over x minus 2 times x plus 2, right, equals, let's see, this is 5 over x minus 2 plus 7 over x plus 2. And I'm just leaving a little space in here so I can write stuff out. If we know our least common multiple, because we can multiply this by x minus 2 to get this by x plus 2 to get this, and this by 1 to get this, then that's our least common multiple. So we need to multiply each individual part. So x plus 2 needs to be multiplied by x minus 2 over x minus 2. X minus 2 needs to be multiplied by x plus 2 over x plus 2. And this one doesn't need to be multiplied by anything. So let's multiply all that out. We're going to get 7x minus 14 over x minus 2 times x plus 2 plus, let's see, 5x plus 10, because we've got to distribute. Don't forget to distribute here. We've got two terms. Divided by x minus 2 times x plus 2 equals 10x minus 2 over x minus 2 times x plus 2. So we have the same denominator all the way across, which says we can just set the numerators equal to each other. So x minus, or 7x minus 14 plus 5x plus 10 equals 7x minus 14 plus 5x plus 10 equals 10x minus 2. And now this is kind of a lengthy algebra 1 problem, but it's still an algebra 1 problem. Let's combine all my like terms on the left side. I have 12x's, negative 14 and positive 10 is minus 4. Yep. Equals 10x minus 2. So let's move the x's to that side because that will leave them positive. Let's move the numbers to the other side. So plus 4, minus 10x, doing a couple things at once. That's going to cancel and that's going to cancel. Fantastic. 12x minus 10x is 2x equals negative 2 plus 4 is positive 2. So we get 2x equals 2, which says x has to equal 1. And don't forget to go back and check it. So our check, we're going to have 7 over 1 plus 2, which is 3, plus 5 over 1 minus 2, which is negative 1. 1 minus 2, yep, negative 1 equals, okay, so 10 times 1 minus 2 is going to be 10 minus 2, which is going to give us 8 over 1 squared is 1 minus 4 is negative 3. So I'm going to type these in and get fractions. So 7/3, or I'm sorry, decimals. It's going to be 2.3 repeating plus negative 5 divided by negative 1 equals negative 8/3, which negative 8/3 is negative 2.6 repeating. So I need to take my absolute value, so my actual number, so 7/3 minus 5, and that gives us, yes, negative 2.6 repeating on both sides, which says that, woohoo, it worked, which says that, yes, x equals 1. So, if you ever get a non-true statement, and you might get some non-true statements, if you ever get a non-true statement for these, you're going to have to say, no, that's not an actual solution, even though it kind of worked out algebraically. Alright, so we have just covered solving rational equations, which are basically equations that have ratios in them. We've just solved checking for our extraneous solutions. So let's get some practice. Let's take our quiz. Good luck, folks.